Greetings, everybody. Welcome to a new virtual day. We have loose end in chapter 3 we're going to take care of first. We have a couple new words here that we'll discuss as we encounter them while doing this problem. So how is today going to work? It's going to work like our last virtual day. So you need a piece of paper. Okay, interesting. Okay, need paper, pen, phone/scanner. Whatever you use to make a scan. And you're going to submit when I tell you. The activity will, it probably appeared a few minutes ago. We're going to try to get 4 activities in and hopefully get done a little early today since we had a test the other day. So this question is a big one on our test. It could be worth up to 18 points on our next test. It's still a chapter 3 item. It's our last thing we're going to look at in chapter 3. And it uses stuff we've learned already, and then we're just going to compare things and label them. So I'm going to start by drawing cyclooctane. So some of you have embraced the circle for rings that are, getting a little bigger. 1, 2, 3, 4, 5, 6, 7, 8. This molecule has groups on 1 and 4. So we got I'll call that number 1, and I'll call this number 4. And we've got a cyclobutyl on 1. Make sure your ring has 4 carbons in it, not 5. I hope when I'm grading your test, nobody put this stick on the middle of a bond. There's videos that say, oh, you just made cyclopentyl group. And there is another group on 1 called an isoheptyl. So that's 6 in a row. 2, 4, 6, V. And then on carbon 4, there's another isoheptyl. 2, 4, 6. 1, 2, 3, 4, 5, 6. V. And that would have to be an H there. Okay, now this is not as tough as a nomenclature question, because you can make this any way you want, and the way you make it should make it easy to do R and S. Make your life easy. Put the number 4 on a dash and you don't have to worry about anything. So to do so, you need to determine what the 4 is. That's the 4. The 1 is the branched carbon in the cyclobutyl. The 2 is the carbon that hits a branch on the 3rd carbon away. And the 3 is the carbon that hits a branch on the 5th carbon away. And put the 4 on a dash. And an adjacent bond must be a wedge. There you go. And that's stereocenter. Now, you got to go from 1 to 2 to 3. 1 to 2 to 3 can only go that way, which is S. I need the S label on here. Just put a big old S there. That's fine.
No.
Oh, it's not S? No, it's R? No, it's S. 1. Now, if you connect 1 to 3 to 2, you're just not following instructions. 1, 2, 3 has to be in that order, which means you can't go to the right. You'll encounter 3 going that way. You got to encounter 2 without touching 3. So it's S. So number 4 on the other stereo center is here. Number 1 on the other stereo center is the carbon that hits a branch earlier. Now, I gotta say, this is hitting a branch before this. It hits a branch on 1, 2, 3, 4, 5th carbon. This one, 1, 2, 3, 4, 5. Oh, I was a little hasty on that one. It still has 2 and 3 in the right order because I don't like this branch carbon as much as I like this branch carbon, which is the same distance away from the stereo center. Okay? This has carbons that go to clearly not methyls. This has carbon that goes to 2 methyls. The methyls are losers. These carbons that are not methyls are winners. All right, make your job easy. Put the 4 on a dash. Adjacent has to be a wedge or else you didn't draw a proper tetrahedron. That one is also S. There you go. All of the hard work on this problem has now been done. You must spend your time only on really the first molecule. Everything else follows patterns that if you follow my protocol, there's a nice system to get you all 4 molecules with the proper drawings. Now, this is a good time to introduce this. Enantiomers are a form of isomer, as you may have guessed. All right? They are non-superimposable mirror images of each other. That's the only definition. If you invent your own definition, it will be wrong. So, keeping the definition in mind, why don't you draw the enantiomer right now? And it's as simple as pretending there's a mirror right here. So I'm just going to draw a pretend mirror right there. You can't barely see it because yellow doesn't show up very well on this screen. And my circle about the same distance from the mirror. I'm not very good at this. I gotta use my hand. Yeah, I got that gap there. I need that gap there. And that's pretty much the same distance from the mirror. And we got this 2 going to 1 going to 4. I guess that's 8, 7. I don't even know. I lost count. 1, 2, 3, 4, 5, 6. And I don't think I spaced them the same. This is not going to look like the mirror image. I'm going to rue the day I made this a circle. I can't even undo what I did. Oh, apparently I can. Okay. My mirror's gone. Okay. Straight across the mirror here. I'm trying to make it a mirror image with the dots. I'm doing much better this time. Now I'm there. Is that 8 yet? 1, 2, 3, 4, 5, 6, 7. And then I guess that's the one, circle 1 there. Okay. So how do you draw the groups? Always talk to me about the mirror. All descriptions are based on the mirror. I want to draw the cyclobutyl. It's towards the mirror and up on a wedge. Towards the mirror and up on a wedge. Cyclobutyl. You do not need spatial gifts to do that. Just follow the words. This is towards the mirror and a little bit down on a bond that's not a wedge or a dash. Towards the mirror and a little down on a bond that's not a wedge or a dash. up, down, up, V. And what about this dash? Well, it's on this bond here. Moving past this one to this one. Describe this bond relative to the mirror, towards the mirror, on a wedge, a little bit down. So that's 1, 2, 3, 4, 1, 2, 3, 4. Towards the mirror, on a wedge, a little bit down. 1, 2, 3, 4. Towards mirror, wedge, a little down. Dash is definitely down and away from the mirror. Here's the rest of that group. It's 6 in a row. 2, 3, 4, 5, 6 with a V. Make sure 1, 2, 3, 4, 5, 6, 7. Good. I think we've successfully drawn the mirror image of that molecule, don't you? I do. What's the mirror image of, well, let's ask this question. What's the mirror image of my right hand? Answer, my left hand. What's the mirror image of an S stereocenter? Answer, an R stereocenter. There's no other answer possible. Likewise, the stereocenter down here, which I think I went a little overzealous on my erasing, and I actually got rid of my stereocenter, which I did all the hard work on. What's the mirror image of the purple S stereocenter? It's the purple R stereocenter. Congratulations, you got a lot more points. Okay. Now I need a strategy that draws the molecule where one of them's S and the others are, because clearly I haven't drawn that molecule yet. I've got this strategy for you. In fact, you know the strategy already. It's called the single switch. The single switch is nice for creating a stereocenter that's the opposite of the original. So what I'm going to do, my strategy for my third molecule on test 2 is to copy my first molecule and do a single switch on maybe just these two groups. Yeah, I'm going to put the 1 where the 3 was and the 3 where the 1 was, and an S stereocenter becomes R. I'm going to copy this stereocenter, and I'm going to have a new molecule that's a third isomer, and it's not the mirror image. It must be this other word, diastereomer. So let's do all of that. I got my circle. I got my blue dots, trying to keep them in the same spots. I am getting better at this. Okay, so I just said I was going to switch those groups. So there's my dash. On the wedge, I'm not going to have the cyclobutyl. I'm going to have 1, 2, 3, 4, 5, 6 V. Okay, and on the normal bond, I'm going to have the cyclobutyl. That's a single switch. Single switch on an S stereocenter means it's now an R stereocenter. I don't have to use my brain. It's done. I'm not finished. It's not R right now. It's not even a stereocenter, but will be R when I'm done. Please don't do a single switch on the bottom one. Do you know what's going to happen if you do that? You will have redrawn this molecule, rotated around. It's the same molecule. You don't get any points. You might as well stop doing the question. All right. So I need the one that has an R up here and an S down here. Please just copy this. Don't change anything. Down there is an H. Down here is an isopentaheptyl. 2, 3, 4, 5, 6. V. Didn't change it. It's still S. That's the third out of 4 molecules. The fourth molecule is easy. Draw the mirror image of this one. Done. We need practice drawing mirror images anyway. Circle. Dots in the right spots. All right. Mirror image of the molecule to the left. On a wedge towards the mirror, slightly up. isoheptal, 2, 3, 4, 5, 6, V. So how would you describe the cyclobutyl relative to the mirror? Towards the mirror, a little down, not a wedge, not a dash. Towards the mirror, a little down, not a wedge, not a dash. Cyclobutyl. Mirror image of an R stereocenter is an S stereocenter. The mirror image of this purple S when I'm finished will be a purple R. Let's make sure it's the right carbon. Yes, on a wedge towards the mirror, down, wedge towards mirror, down. 2, 3, 4, 5, 6, V. And then H, down, away from the mirror. End of story so far. You now have 12 out of 18 points. And then you're going to get the 6 fastest points ever on an exam. Because of your strategy, you've guaranteed that those 2 pairs are each called. They're non-superimposable mirror images of each other. What does that make them called? Big E. The only reason you can use big E is because I told you you could. Big E stands for enantiomer. Same story down here. What does non-superimposable mean? It means if I tried to just grab this molecule and put it on top of the other one, the parts wouldn't match up. And they wouldn't. Okay, just like you can't match these parts up when you try to put your right hand down and then left hand on top of it. A pinky does not match a thumb. Similarly, an index finger doesn't match a ring finger. This thumb doesn't match this pinky. They're not matching, so they're non-superimposable mirror images. What's the relationship between your hands called? Because they're non-superimposable mirror images? You said it, enantiomers. Okay, now, these 4 we'll do in baby blue. That pair, this pair, this pair. Oh, this is getting tricky. There's a pair. And this one's hard to do. I'm going to go with yet another color. I don't know, gray. Those are all called diastereomers. I need 4 diastereomer labels in this molecule, and I have them. There's your 6 points. So what's a diastereomer? Well, it's not a mirror image. No. All the parts would have to be opposites to be mirror images. And it's not the same molecule. All the parts would have to be identical. But that has the same name. Do you agree? They're all called this. So they've got the same name, diastereomers. And some of the stereocenters are the same. And some of the stereocenters are different. Is that true for every D label? Pink changed. Purple stayed the same. Go here. Pink stayed the same. Purple changed. Let's go gray. Pink stayed the same. Purple changed. Let's go far right. Pink changed. Purple stayed the same. So some stay the same, some change. That's diastereomers. That's the end of the video. 18 points of fun. So I'm going to change the submission area, but not much. It's going to be due at 11:35, and we will reconvene at 11:45 because some people had some technical issues. So you have until 11:45 to get this submitted. So I'm going to make it so you can screenshot it. Oh, I can't do that now. Back to the sharing. Sorry about that. Wasn't thinking properly. Saw starboard. You want to I can't get it smaller. There it is. There, everything you need is here. This would be the time to screenshot it because I am going to say goodbye. All right. And I need this copied onto a piece of paper. You don't have to copy the question. Please don't do that. And you've got to 11:45.